Hi, everyone. Thanks for joining in and tuning in to the Printed Circuit Podcast, where we discuss trends, challenges, and opportunities across the printed circuit engineering industry. I'm your host, Steph Chavez. Last year, we spent several episodes talking about supply chain and the road to resilience for PCB designers. This season on the Printed Circuit Podcast, we'll be discussing PCB design best practices. In each episode, we'll focus on one of the PCB design best practices. This week, we will discuss ECAD MCAD collaboration, and here to join me is Alex Grange. Alex Grange is a technical marketing engineer for the electronic board division at Siemens, focusing on electromechanical collaboration, and is currently the leader of the ProStep ECAD MCAD implementer forum developing the IDX standard. Thanks for being here, Alex.
Thank you for having me. I'm happy to share my experience on this subject.
So let's just get right into it. Alex, why doesn't it work today when it comes to ECAD MCAD co-design collaboration?
Most issues with collaboration can be traced back to the limitation of the format that was being used during the collaboration. Today, the intermediate data format, or IDF, and data exchange format, DXF, has been widely used to exchange PCB data between mechanical and electrical designs. IDF was initially developed and released in 1992 and was last updated in 1998. DXF, on the other hand, was released in 1982 and is no longer being developed either. For older designs, IDF and DXF provided a powerful mechanism to collaborate between electrical and mechanical domains. However, with the evolution of the workforce, the ever-changing product complexity, and the scale of the products we design, these static formats can end up hindering the design process instead of facilitating it. Problems resulting from electromechanical interference are becoming more common as designs face tighter restrictions. Handling these problems across disciplines requires constant collaboration and synchronized data. The IDF process flows really restricts the frequency of electromechanical collaboration, and IDF requires the entire data set to be transferred for each incremental collaboration exchange. Exporting collaboration data often causes electrical designers to either manipulate or misinterpret information or even manually recreate the data that was sent to the mechanical designer, or vice versa. Identifying and reviewing both sides of the electrical and mechanical design is tedious, and it can take weeks to determine whether a manual tweak created a fitment issue in the mechanical enclosure. Given the tight requirement of modern designs, the entire database needs to be represented. A very common issue for electromechanical designs is the necessity for representation of copper data in the mechanical assembly. This not only helps to identify assembly shorting, but also is necessary for thermal simulation. DXF, on the other hand, does not provide any intelligent information. Therefore, it is up to the designers to identify and understand how each individual draw item is associated with each item within their design. The gaps in information between electrical and mechanical design significantly increases with design complexity. Additionally, divisions function more as a silo due to the globalization of engineering groups. Designers face both regional and time zone challenges when identifying the true design intent the other domain is trying to convey. This lack of intelligent communication has resulted in duplicate work and tedious rework to understand the full set of requirements set by both electrical and mechanical domains.
Alex, I couldn't agree with you more on that. And I'll tell you, I've had my share of evolution throughout my 3 decades of experience, from going from napkins to drawings to PDF or even Visio files to IDF or DXF, and then now with IDX. So I hear you. Do you have any examples to share where you have encountered problems using these older formats?
One very common theme that I have encountered is that the electrical and mechanical divisions of most companies are divided, and that means they follow their own separate standards. Without a synchronized library structure, the collaboration between ECAD and MCAD designs often will have components that are offset or rotated. One example I've seen is that the mechanical designer will send an initial baseline set of data to the ECAD designer, And right after it's applied, the ECAD designer will immediately send a DXF file right back at them. This allows the mechanical designer to overlay the placement outline, the component shape, on top of the components in the mechanical assembly. And they have to manually comb through dozens, if not hundreds, of components to see if any component is offset. This also doesn't help if the pin 1 location in the mechanical library is rotated 180 degrees from the electrical library. I have seen this disjoint cause many design respins because the component looked like it was placed in the right location in the same X and Y in both ECAD and MCAD assemblies, but the pin 1 was different. So when you fabricated and inserted the component, it did not actually work. But this really is only the tip of the iceberg. Every company I have visited and worked with has their own story of how a small mismatch between the ECAD and MCAD data has resulted in a design respin that costed the company a lot of money.
I've seen it over the years. I've seen not just me, but other designers I talk to that have vast experience can tell you that those issues have definitely crossed our plate at one time or another. So that is so true. I can tell you that for sure. So tell me, what is the IDX format and how does it benefit electromechanical exchange today?
When the ECAD MCAD Implementer Forum was first formed to develop the IDX standard back in 2010, the main intention of it was to replace IDF and DXF and provide a more incremental exchange rather than dumping all the data to the other side. With IDX, we created a collaboration workflow. This workflow allows you to accept or reject any proposed items that have been sent from either domain. To keep the data synchronized, every proposal comes with a response from the other domain. This helps you understand what the current status of the board is between both domains to ensure that we stay in sync with each other. We also know that it's much easier to fix the problem as you encounter it rather than doing a long design review at the end and updating the project when it's complete. We also wanted to provide a higher resolution of data exchange between ECAD and MCAD. Since 2010, we have added 9 major schema updates, where we have a wide range of features that we have supported, from copper, solder mask, and silkscreen objects, support for flex and rigid flex designs, the passage of stack-up information as well as the primary pin, and a whole load of functionality that should make collaboration even easier and build some of the electrical data that was missing in the mechanical assemblies that's needed while you're doing your design. It is important to understand that we need to move away from these obsolete data exchange formats that are no longer being developed by any vendor and move toward an incremental data exchange, which is the IDX format.
I couldn't agree with you more, Alex, especially when you talk about the integrity of the data and the accuracy of the data. It's important. I can tell you how many times where I too have heard horror stories of the exchange not going as well, or it's a manual process, and that manual or the human process, stuff will get missed. It's Murphy's Law. If it's going to happen, it will happen, or potential to happen, it will happen. So let me ask this. So when we know what the problems can be, what is the solution? Or when we think of best practice, what is the best practice that PCB designers should implement?
The communication between the electrical and mechanical designers should be able to occur at any time or frequency. As a result, this simplifies the exchange process, as we are only sending the incremental data, allowing us to collaborate more often and earlier in the design cycle. Being able to see only the items that have been added, modified, or deleted is extremely important, as we are trying to find out what has changed in only a couple dozen components rather than the entire database with over tens of thousands of objects. This will not only ensure design consistency and synchronization, but allows you to left shift your current process and detect violations much earlier in your design. One example I have is working with a customer over the last year who was still using IDF, is that the mechanical designer made dozens of redundant iterations with the ECAD designer on a connector on their board that interfered with their enclosure. The ECAD designer did not know there was an interference and would move it for better routing, and the mechanical designer would push it back to its original location as it did not interfere with the enclosure. With IDX, we can reject any changes that were proposed and even provide a comment to the other domain to highlight the intent of why the change was rejected. Additionally, the Expedition and NX databases are sharing the mechanical models directly from the mechanical assembly to the ECAD designer. In the PCB layout, the designer can see in real time the interference he is causing by moving the component closer to the edge of the board and interfering with the enclosure. With IDX, users have access to all relevant information in the other domain. This improved two-way flow of information avoids potential issues and accelerates the project development.
I couldn't agree with you more, Alex, especially regarding the significance of bidirectional communication as well as continuous communication throughout the entire process, especially when we think of the full cycle of the design process. Can't communicate enough, and knowing the integrity of the data as well as what changed, when it changed, and how it changed is key. And knowing that is extremely important throughout the process. Can you walk me through how this might work in real life regarding the IDX exchange?
In most electromechanical projects, critical design constraints are first defined by the mechanical designer. This means the mechanical engineer usually defines the board outline, mounting holes, placement, routing keepouts, connector placement, and other objects that may be critical for their design. This data is then exchanged with the ECAD designer to ensure that the correct information is used when they start their PCB layout. This initial exchange would be the baseline file, and this is the same as if you were using the IDF, as it will contain the entire assembly from the mechanical domain over to the electrical domain. However, that is the only similarity between the two. With the IDX standard, you can go beyond sending a single static file to and from each design team by allowing each domain to send incremental data, which only consists of the elements that have been added, deleted, or modified. Since the last incremental or baseline you have sent, any item in the incremental data will be allowed to have a comment associated to it and can be accepted or rejected. To ensure both domains stay in sync, each proposal will have a response file. If a component was moved and rejected, the initiator will see that the component will move back to its original location. This process continues throughout the entire design cycle until the project is finalized and sent off to be manufactured. IDF really fosters closer collaboration and enables the early identification of critical issues during the design flow.
Yeah, I tell you, I really love that. I love the fact that you know what changed, who changed it, why it changed, or what is the proposed change. And I think, especially from what I know now after 3 decades of doing this, it's the intelligence at the point of design is key, especially when you're cross collaborating, not just with multiple domains, but with multiple disciplines as well. So what do you see as the roadblocks to implementing this kind of best practice?
One of the biggest roadblocks are self-imposed. People have been using IDF and DXF since the 90s and have created their own corporate workflow to electromechanical collaboration. When something is in place for 30 years, it has deep roots. Another roadblock is often the ECAD and MCAD divisions are siloed and often don't integrate unless required by senior management from both divisions.
Coming from my background in the mill aero, especially these anywhere between 10 and 20 years, the siloed functions and the way teams are in their specific swim lanes. And that is so true. It's so true when we talk about, you have these siloed or these walls in between the different domains or the different disciplines. And that just adds more complexity to it in itself. So I can definitely feel that every time when I think about how companies overall function and how they could potentially be better. And specifically when it comes to roadblocks and self-imposed. And yeah, definitely legacy companies have their way of doing things. And it's sad to say that the saying of, we don't have enough time to do it right the first time, but we always have enough time to do it again. Looking at their processes and how they do things could definitely be improved if they just take the time to do it. But quote unquote, they don't have the time because they're jumping from one project to the next, but yet repeating the same manual steps. So tell me, How do you think someone could overcome these roadblocks within their organization?
If you look at the complexity of products that are being sold today, processes built in the 20th century don't really have the power to address the problems we have today. And this is the reason why we developed the IDX standard. We are creating products where there is a 1 micrometer clearance between the PCB and the mechanical enclosure. One company I worked with reviewed all their PCB design respins over the last year. They found out that the number one cause of respin was due to mechanical interference. They found out that this was the cause for over 60% of their overall design respins that year. I know moving to a newer format always has a risk associated to it, but the current process is far from perfect and is causing design respins today in all industries around the world. I want to put out a challenge out there. If you're looking for better collaboration between ECAD and MCAD divisions, you need to start looking towards the future, and that's with IDX, and stop using a format that hasn't been updated in this century.
Yeah, that's definitely the challenge. There you go. You had it. You heard it. Alex has put the request for a challenge out there. Step up to the new IDX format and get with the 21st century. That's for sure. This is when it comes to MCAD, ECAD collaboration. Thanks again, Alex, for your invaluable insight and testimony of what you've given us today. Much appreciated. So tune in to our next episode where we continue to talk about collaboration, only this time being between design and manufacturing.